Hello class, so today we're going to be learning about upper and lower bounds. And so to sum it up and make it a lot more simpler to you guys, but to sum it up and make it a lot more simpler, it is the ceiling and the floor at which a polynomial function performs itself. It is the x horizontal line on the positive side that which the function cannot go above, and on the negative side, the x horizontal line that the function cannot go below. And so you find these upper and lower bounds when testing for real zeros in the polynomial functions. And the real zero part is very important because that's kind of how you complete this task. So here we go. So the equation that you'll be trying to do your math off of is basically this equation right here. Forget this. That's a problem that we'll practice. But it's technically, in speaking terms, f of x equals x minus k. G of x equals x minus k, g of x plus 0. And so that the constant value k will be the set of upper bounds for the real zeros if and only if f of x is never 0 and x is more than k. I'm going to say that one more time. So the constant value of k will be the set of upper bounds for the real zeros if and only if f of x is never 0 and x is more than k. And the same applies for the lower bounds. K will be the set of the low bounds for real zeros in the equation if and only if f of x is never 0 and x is less than k. It's all about, it's an if game. If I'm trying to, make it simple. If this is this number, then it's a lower bound. If this is that number, it's upper bound. Technically, it takes more practice, So there's a two set of guidelines and rules in which you have to perform these findings for real zeros and upper and lower bounds. So the one guideline is if and only if k is greater than or equal to 0, every integer in the final line of the equation is positive or 0. K is then set to be the upper bound for f. So f is controlled by k, right? And as the second guideline is the complete opposite. But I'm going to say it one more time. If and only if k is less than or equal to every integer in the equation, it is a non-positive. K is a set of lower bounds. So basically, we're working off of non-positive for lower bounds, not non-negatives for upper bounds, and we'll go through that in a practice problem. So yeah, again, it's a support system and helps the function not run vertically or run wild, I like to say. Right, so in a real life kind of simple setting, this isn't a problem that we will be having in our section, but it helps to know this, So a mass of 70 kilograms rounded to the nearest 10 kilogram, 10th value, has a lower bound of 65, and that's it. Why? Because 65 kilograms is the smallest mass that rounds to 70 kilograms. Now, I hope that makes sense to you guys, right? And the lower bound is the smallest value that would round up to the estimated value. The upper bound is the smallest value that will round up to the next estimated value. That's kind of how it works, but we won't be doing problems like that. We'll be more doing problems like this, okay? So the equation is, we're saying find the upper bound for 3. We're trying to find 3 and make it, known that it's 3 for the upper bound. 4x to the 4th minus 6x to the 3rd minus 7x to the 2nd plus 9x plus 2 as your equation. Write it down in your notebooks and we'll walk through it. So you set up something like this. Hope you guys can see. So you put 3 and then you make it kind of a reverse divisional problem. So 3, that's what you're aiming for as a target, correct? This top line is all these functions up here. As you can see, they match with each other, right? 4 doesn't have one under because it's the first value. Now, these numbers all came from, the most that it can be, and we'll talk through that. So basically what you want to do is you want to add this. So you get 4, then you get 6, then you get 11, then you get 42, and you get 142. Now, as you can see, these are all non-negatives. Now, what happens when we get a non-negative? It proves the theory that 3 is the upper bound. Now, thank you guys for listening. And yeah, that's it for upper and lower bounds.